Hello, everyone, and welcome to the week's workshops. I will be your MC today. My name is Lina Mariette. I am a scientist with a PhD in physics. I'm an entrepreneur and consultant, and I love to provide guidance to women who want to make a career switch to the amazing world of data science and AI. In today's workshop, we're going to come back to the roots, and we're going to learn about a fairly common topic in data science. That's the basics of machine learning. After today's workshop, you will have a solid foundation in machine learning principles, and you will also gain the knowledge and skills to explore more advanced topics, and also maybe start playing machine learning, using it in your own projects. The workshop title is Machine Learning Basics, and we will present it by Sanduni Jayasundara. She is a machine learning engineer with 5 years of experience implementing end-to-end machine learning solutions with machine learning operation practices in the industry. She has also generated insightful reports for senior management, including analytical processors. Sanduni will answer all your questions, so please add them into the Q&A as we go. And without further ado, please welcome Sanduni.
I am Sanduni Jayasundara, a machine learning engineer, and I have worked in the industry for like 5 years now in different industries like finance, retail, and also in telecommunication. So today I'm honored to deliver the session, Machine Learning Basics, at with Datathon 2014. So now I will go through the agenda for today's workshop. First, I will go through understanding the data types. There, I will explaining what are the data types available for most of the data science projects and how to differentiate them. And then I will go through the data pre-processing techniques. What basically in here, I will explain what we should do to get some insights and prepare our data set before we feed data set into a machine learning model, machine learning algorithm. And after that, I will show you how to do exploratory data analysis, which is called also an EDA, to get more insight and to see the relationships between data variables in a data set. Next, I will introduce you to machine learning algorithms. Basically, most basic algorithms like regression, classification, and clustering will be discussed here. After that, I will take you through the advanced topics in machine learning, which are some of the trending and most of the people are interested in some of the topics which are emerging in these days in the machine learning field. So then next is the finally I will take you through the Google Colab as the hands-on practice session, and I will show you how to apply the explained techniques to use a machine learning algorithm to using machine learning algorithm, train them, and how to do predictions and evaluate those in that session. So as the uh, first topic, I will take you through the understanding data types. So here basically I will see what are the main two data types available. So there are two data types as quantitative data, which is also called numerical. Also, the other type is qualitative data, which is also called as categorical data. So, as quantitative data, we can say quantitative data also as numerical data, as I mentioned earlier. So here we can divide these numerical data into another two different categories, which is called decreased and continuous. In discrete, we have the count in numbers like in the example shown here. If we can hire only staff members should be whole numbers like 1, 2, 3. There shouldn't be 3.5 members should be there like 2.75, 3.5. Those are not discrete. So the other type is continuous. So continuous data type is they are the numerical data which also can be fractions, also like 23.5, 23.57 as in the example, but also it can be 23 also. So as we all know now, the Python is the most famous programming languages used among the data scientists. So in the Python also uh, to represent those quantitative data, we have data type defined in Python programming, which is basically as examples, integer, double, float, complex, those kind of data types are considered as quantitative data types. And then I will explain what are qualitative data. So here, uh, qualitative data is the categorical data, which we can further divide into another two categories. One is nominal. Nominal data can be fit to various categories, like it should be specific category, like if it is in clothing, it should be shoes, tops, and pants. It shouldn't have an order to describe those categories. In ordinal data, that data can be ranked to order. There's a specific order that we can define those data. So as in the example, if we consider a company, there might be designations like assistants, managers, and directors. So their assistants will be the lower level, and if we consider the directors in the higher level, so there's the order when we go through the designation levels. So these are called ordinal category. So in Python, as similar to quantitative data, for the qualitative data also, there are data types as string, boolean, and dictionary. And there are more types also. So then next, what I will explain is about data preprocessing techniques. So here we will first see why we need data preprocessing techniques and what are the data preprocessing techniques. So basically we need data preprocessing techniques to handle missing values and encoding categorical variables. So further, if we go to see why we need to handle missing values is there might be cases that data entry errors has been occurred, or else maybe data collection issues has been occurred due to some technical issues, maybe instrumental issues, or etc. And or maybe there might be some missing of sensitive data, like people do know, like we can't sometimes collect the sensitive data of people, like birthdays, credit card numbers, those kind of one. So in those cases, that data might go missing. So why we need to handle missing data is most of the machine learning algorithms does not support this missing data. So we have to either remove those missing data, or we have to have a technique to replace these missing values before we uh, feed this data into a machine learning algorithm. So first we will see how data can actually go missing. So here there are three ways we can define it overall. So first one is data can be go missing completely at random. So here what happens is, in a column, we can if we consider data set which has 12 columns. So in one column we consider as a feature. So if that feature has not any dependency from another feature to have a data point, and if there's a data point that has gone missing, that is called as missing completely at random. So there's no any dependency with other column to go missing. And the next one is missing at random. So what happens here is, there might be cases that data point has been missed because due to dependence of another feature. As an example, there's a column that we calculate age by considering the date of birth. In that case, we can see that the age column has gotten missed value because of due to birthday column has the missing value. So this is called missing at random. The other one is, the last one is missing not at random. So here what happens is, so this shouldn't have gone, in here we define that the data point shouldn't have gone missing uh, due to any randomness, but it should have a reason to go missed, because imagine that in a survey some questions has been completely answered from by people, but there's a question that no one has been asked or answered, or only one or two has been answered out of 1,000 responses. So in that cases we have to revisit and see whether why they haven't answered, whether they didn't answer the questions, or whether we have tried to capture sensitive data or something like that has happened before we decide anything about that data point. So those are the three main things that how the values can go missing. So next, I will talk about how we can handle those kind of missing values. So first one is we can ignore those missing values. And the next one is we can drop missing values. There are two ways to drop missing values. Either we can drop a variable or we can use case deletion. And the last one is imputation. Under imputation, we can use mode, mean, or median to impute the values, or else we can sometimes use regression methods where we can use regression and predict the missing data point, or else we can use k-nearest neighbors imputation, or we can use multiple imputation. So I will discuss all these things separately in the coming slides. So first one is ignoring missing values. So just because some of the values has gone missing in the data set, we can just ignore those values. There are some conditions that we have to consider before we ignore those missing values. So there are two main things that we have to consider. One is we have to see whether the the missing data is below than the 10% of the full data set, and also it shouldn't be gone missing under missing at random or missing not at random. So in that case, we can see whether we can ignore the missing values, and also we have to check, though it is under 10% of the whole data set, if we remove those data, whether the data is sufficient for algorithm to, and some analysis to be done using that remaining data set. So if these two are can be proceed with these two, then we can decide to ignore the missing values and go ahead with the remaining data set. Next, we can drop missing values. So here, first is dropping a variable. So if the data is missing completely at random or missing at random, then number of missing values in that feature is very high compared to the data set. Then we shouldn't we should left out that variable. Like we can completely drop that variable and go ahead with the analysis or the model training. If not, we can use case deletion. So in case deletion, we can check and see why these missing values has been occurred, whether there are like two or more features been affected with this. If in that case, we can delete those one or more missing features, but this is very easy, but it might also reduce our sample size in the data set, which is affecting again with the model training or the analysis that we are going to do. So therefore, we have to mindful before we drop any variable from the data set. So the most of the time we use imputations when the data set is very small, or like we are having difficulty to find best data set, which is also the data set should be the data sets samples, okay, class should be uh, normalized and everything should be fine. Then we can just go with the other method, or else we can use imputation methods to keep our data and go ahead with the data set and do the meshing to use these data set to algorithm for training. So for imputation, there are several methods. One is, as I explained earlier, we can use mean, mode, median, or statistic mid-mod median by but this method can be used only for numerical features. So we can have a look how the columns data is being uh, behaved, and then we can decide whether to use mean, mode, or median, and then we can calculate and replace the missing values with that value. And otherwise, we can see whether we can use regression methods. When we use a regression method, what we do is we will consider the we will consider the variable which has missing values as the dependent variable, and the other variables as the independent variables to predict the dependent variable. And we can use that technique and replace the missing values with regression method. So, and also we can use k-nearest neighbor imputation. In k-nearest neighbor imputation, the k-neighbors are chosen using some distance measure, and the average is used to replace the missing values by the estimate of that value. So that's how the k-nearest neighbor imputation be used. And the last one is multiple imputation. So here what we do is we will impute the missing entries of the incomplete data set m times. But what we do is we impute those values are drawn from another distribution and replace those values in the data set to handle the missing values. So those are the 4 techniques we are mostly used for imputation of the missing values. So now I will explain how to use encoding techniques for categorical variables. So here, why we use to encode categorical, why and how we do the encoding categorical variables is to basically, most machine learning algorithms can't support categorical data. It should be a numerical data that has to be inserted for a machine learning algorithm to train or predict some value. So therefore, what we do is mostly we convert all the categorical variables into a numerical data point, and then we will be go ahead with the analysis or the model training. So here we can use several encoding methods. First one is one-hot encoding, binary, and then binary encoding, also frequency encoding, label encoding, and ordinal encoding. So we have to select the best encoding method for the variable that the categorical variable that we are going to proceed the encoding method. But also we have to be mindful about selecting the encoding method, because the performance of the ML algorithm will be varied based on the encoding method that we are using for the categorical variables. So I will explain what happens in all of these encoding methods one by one. So first is one-hot encoding. So As you can see, in the right side table, we have encoded the column called color. So you can see in the left side. So what we have done, done here is, so we have one column with three categories, namely red, yellow, green. So we have created three more columns for each of the colors. So after creating that, we encode the specific color in the color column in those three columns in a way that only the column has the relevant categories name. That means if in the first data point, if it is red, then we insert 1 in the red column and we put 0 in the other column. So that is one hot encoding. So in the second data point also, we have red. So we put 1 in the red column and the other two columns are 0. When it comes to yellow, we put only 1 in the yellow column and other two columns are 0 in the third data point. So likewise, we have to fill the generated columns. That is called one-hot encoding. Next one is binary encoding. So here what happens is we will create first we will create a order column, and then we will convert that order number into a binary number, and after generating the binary number, we will create another columns to indicate each of the digit of that binary number. So here, if you can see, as you can see in the first column in the left side, so in as temperature, you can see hot, cold, very hot, warm, and again hot. So here, when we numbering when we fill the order column, what we do is we assign the first data point as 1, and then the second data point as 2, and the third data point as 3. But if we change the order number if it is a different category only. But when it comes to again the same category, we put the number that we used earlier for that same category. So you can see in the fifth data point, when it comes to hot, again, the number we have used is 1. So likewise, after that, we convert those numbers into binary form. You can see in the column name binary. So here we have 3 digits. So for each of the binary digit, we create another 3 columns. So we fill those generated columns named as temperature 0, temperature 1, temperature 2. We will use the first digit in the temperature 0 in the first digit in the binary column for the temperature 0 column. So that's how we fill the binary encoding feature columns. So here you can see for the first record, temperature 0 is 0, temperature 1 is 0, temperature 2 is 1. And the second data point, temperature 0 is 0, temperature 1 is 1, temperature 2 is 0. Likewise, we have to fill the rest of the data point. So that is called binary encoding. Next is frequency encoding. So here what we do is we will calculate the relative frequency of each of the category and then use that value to encode the feature. So as you can see here, there are 9 data points here in the right table. In the feature, we can see 4 A's, 3 B's, and 2 C's. And in the left side of there's another table. You can see small table where it says A is 0.44 that has been calculated 4 out of 9, that means 0.44. After we get the relative frequency, we will encode the value in the encoded feature. As you can see, for all the A's, we have used 0.44, and all the B's we have used 0.33, and all the C's we have used 0.22. So this is called frequency encoding. Next one is label encoding. So in label encoding, what we do is we will assign just a number to each and every category in the original data set. So in the left side, you can see there are 3 categories as A, B, and C. So for those categories, we have encode A as 0, B as 1, and C as 2. Just a unique integer number that we have encoded into the related category. So that's how the label encoding is carried out. And final one is ordinal encoding. So here, as you can see, there's a column called breakfast in the left side of, and then here there are the categories like how often you use breakfast, like every day is one category, never is another category, rarely is another category, and most days is another category, where we have 4 different categories. So when we encode this, we don't use like randomly. What we do is we, according to the weight of that category, we use the numbers. So every day is encoded as 3 because every day means it has more weight into that category, and never is 0. Like that way, there's an order. We can't just define randomly the integer numbers randomly. So we have to consider the weight of those categories, and then we have to order it, and then we define what's the number that we should encode for each of those categories. So that is called ordinal encoding. Next, I will explain about exploratory data analysis, which is also called EDA. So here we'll see what is an EDA. So we use EDA to analyze and investigate data set and summarize the main characteristics, often employing data visual method. That means we want to see summarized characteristics by using visual methods like bar charts, pie charts, and things. So we can get overall good idea about the data set and how it behaves and what kind of data it contains. And if it is a categorical column, what are the categories it has, like those kind of things we can explore in the EDA by conducting an EDA. So key features of the EDA uncover the underlying data patterns, also grasp the data set structure, identify any potential anomalies or relationship between variables. So those are the key features that are expected from an EDA. So as the first step of the EDA, what we have to do is we have to load the data. So data can be available in different data sources in different formats. So to conduct an EDA or start working on a data science project like model building or prediction or anything, we have to load the data and load the data into one place. So in this step, what we'll do is we will load the data from those sources for our analysis. After that, we will do mostly like this data will be in tabular format. If it is, sometimes there might be the data available in video and audio, that also we have to convert into a way that the machine can read and we can CEO, we can analyze that data. So after we got the data, we will as a first step, what we will do is we will conduct some statistical analysis, like distributions and their behavior, and we will see what are the initial insights that we can get from this data set, and from that we will see what are the further explorations and in-depth analysis that we can get as summary statistics from this data set. So that's the next step of the EDU. After that, we will see if we can do the dimensional reduction. Dimensional reduction is there might be data that has a high dimension, so where it is very difficult to understand and see or gain insight from that. Therefore, what we do is we will reduce those high dimension data, so we can discover hidden patterns in hidden semantic patterns with the data set. So for this, we will use a technique called principal component analysis, or T-distributed stochastic neighbor embedding. These will reduce the number of variables while the most of the original information is available. It will not harm the information which was available initially. So this is called dimensionality reduction. After that, what we will do is we will do the data preparation. So in data preparation, what we do is we will transform, aggregate, and clean our data set before we do the further analysis or predictions. So in here, we can conduct grouping, appending, merging, sorting. Also, we can delete the duplicates in this step and clean the data set. Once the data set is cleaned, we can now visualize and see the clean and proper data set. And after cleaning, we can identify the trends of that data set. Also, we can find the relationships between each of the variables, and we can find the outliers of that data set easily. After that, what we will do is we will do we are performing the variable analysis. So in performing variable analysis, it provides insight to the distribution and correlation between the data sets variables. So there are three types that we can conduct this. So one is univariate. That means we have a single variable and we plot it and see how the behavior and the distribution of that variable. And the other one is bivariate. So in bivariate, what we do is there will be two variables. We will plot it and see the pattern and the behavior of those two variables among each other. So as you can see in the second image, how the data is being plotted and its relation is being showed after we use those for variable analysis. So in the last one is multivariate, and in the last image you can see there are more than two variables and how the data is being spread among those three variables and their relationship among each other. So that is called multivariate. So these are the three main ways that we can conduct a variable analysis. Next one is under EDA, we can analyze the time series data. So, and when it comes to analyzing time series data, what we can do is we can get some regular time intervals, and then we can apply those time series data into that time intervals over that time, and then see what are the trends of those data between between each and every time frames. So this basically means the data set is composed of a group of data points that are recorded over regular time intervals. So as you can see in the picture, you can see the forecast and average temperature, how it has been behaved uh, within the years, between the years 1980 to 2022. So you can see the trend, it has gone up and down, and how also how it has been varied among the two variables as well. And next is sometimes we conduct the hypothesis testing. So formulating and testing hypothesis is about the relationships between variables. So here what we will do is we will here we will check whether the observed pattern, the determining of the if the patterns observed in the data are statistically significant or if they occurred by a chance. So that's why we are conducting the hypothesis testing and see how the uh, data can be determined. Next, I will explain next I am going to uh, go to the most important topic of this workshop, which is introduction to machine learning algorithm. So here, firstly, I will explain about regression. So in regression analysis, it's a set of statistical process that we use to estimate the relationship between a dependent variable and one or more independent variable. So as you can see in the graph, you can see the independent variables in x-axis and dependent variable. This is a linear line. So basically, you can see the data points shown in blue colors, and the line of regression means the relationship is shown in the middle black line. So there are several types of regression. So one is linear regression and nonlinear regression, logistic regression. So in linear regression, we have a linear uh, relationship between uh, dependent variable and independent variables. But in nonlinear regression, we don't we every other the other relationship other than linear regression except from logistic regression is falls under linear regression. That is basically we will get a curve for the, if we plot it, we will receive a curve for the relationship of these variables. So that is called linear regression. And for the logistic regression, what we get is what we can use it for, it's a logistic curve we can see as a relationship, but ultimate output will be binary. It will be basically whether it's 0 or 1, or maybe we can like basically use logistic regression mostly for classification as well, like uh, to answer questions like yes or no, or whether it's a cat or dog. So in like those kind of situations, we can use logistic regression. So the other type is classification. So in classification, the classification algorithm is used to identify the category of a given data set. So basically, we have a data set. So we have to we have to predict whether, imagine that we have to predict whether the given person is a male or a female. So in that cases, the algorithms that we are used to predict that is called classification. So we are using label data for this to predict the related class. So there are two ways. One is a binary classifier and the other one is multi-class classifier. In binary classifier, we have only two classes. as example, yes or no, male or female, or spam or not spam, or maybe a cat or dog, like that. And then we have multi-class classifier, the classification which is has the type of crops or maybe types of music, which is like more than the classes which has more than two are falls under multi-class classifiers. So that's about the classification. So next one is clustering. So here we are using unlabeled data for clustering. Basically what we do is we are grouping unlabeled examples to predict which cluster that specific data point is be related to. So this is a type of the unsupervised learning as well. And also we don't need to label this data. It by the algorithm itself, it will identify which cluster a specific data point is falls under. It will identify the similar characteristics of those data points and cluster into separate clusters. And uh, then once we give a once we want to do a prediction, by the algorithm itself, it will identify which cluster the given data point is falls under, and it will predict the cluster. So that's where we use clustering. And there are several clustering methods, k-means, mean shifts, and DBS scan, and hierarchical, and PIRCH. So those are the clustering methods that we can use. Next, I will going to explain about the advanced topic in machine learning. These are also some kind of trending machine learning topics in the world currently. So first one is the first one is deep learning. I think most of you are aware about the deep learning as well. And next one is reinforcement learning, which is mostly being used for robotics and self-driving cars like use cases. Reinforcement learning is being used. This is a very trending topic, and most of the researchers are conducting at the moment in the world everywhere under this topic. And the other one is, the last one is generative AI, which is a hot topic on these days. I will briefly explain about those things in the coming slides. The first is deep learning. So I will briefly explain what is deep learning is. So we know that artificial intelligence is the technique that enables computers to mimic the human behavior. So it's a wide area. So it has different techniques, but what we are focusing about a part of that whole broad view of artificial intelligence, which is called machine learning. So under the machine learning is used to learn without explicitly being programmed. So basically, machine learning is where we don't ask machine to do whatever we need, but we give the data, and machine will train itself, and it will understand what it has to be done, and then it will be predicting for a given new input in the future. So that is called machine learning. So inside machine learning, there's another subpart called deep learning, where the deep learning is the way that extract this pattern from in given data using neural networks. So these networks are connected to each other. So if you can see in the input layer, we are giving the inputs to the deep learning like a neural network, and there are like hidden layers. And so in the hidden layer, these inputs will be computed in a way that it can predict the related prediction from the output layer. So that is how deep learning works, and it's a unsupervised learning techniques. So there are most common types in deep learning, as I mentioned in the slide. So these are the most common types. First one is convolutional neural network, which is also called CNN. These are used for image recognition and processing. Basically, there's a kernel. Uh, you can do poolings and everything in convolutional neural networks. So mostly this is for image recognition side projects. We are using those. And the other one is deep reinforcement learning, which is used for mostly to robots and game playing. Here also we have agent, and also it's also agent which can work as a uh, agent which is which can decide the inputs and also the calculations inside a neural network, and then it also works towards a reward getting, and it the agent will work towards maximize that reward in its state. That's how the deep reinforcement learning is works. So the other one is recurrent neural networks, which is also called RNN, and it's used for natural language processing, speech recognition, and time series data. Basically, RNNs are used for sequential data, so that's why it's specialized for NLP and speech recognition, like use cases, use case development. So that's about the deep learning. Then I will explain what is reinforcement learning. So here, reinforcement learning is learning what to do, how to map situation to the actions, so as to maximize a numerical reward signal. So as you can see in the image, so the agent is working in a environment. So in that environment, in a specific state, he will do an action. So after doing that action, he will get a reward. So according to that reward, it will so that reward should be maximized. So it will use its best to get maximize its reward. Like imagine if we do a wrong action, it will get a minimum or minus reward. So we can define those. The policy is where the agent's strategies are defined. So that policy also can optimize so that the agent can get the maximum reward. And then before, once it's like all the policies and reward, all the algorithms have been optimized, before the agent is go and do a specific action, it will predict the reward, and then it will proceed with the action with the maximum reward. So that's how the reinforcement learning is defined. So this reinforcement learning is mostly used in gaming, robotics, autonomous vehicles, and healthcare sectors. And now it's been used in like many more sectors than this. You can search and see if you are interested further. And next I will talk about the generative AI, which is a hot topic these days. So here, what generative AI is, also called generative artificial intelligence. It describes the algorithms such as ChatGPT, Code Llama or Llama, BART, so those kind of algorithm. So basically, we use generative AI to create new contents or to process audios, code generation, image generation, text generation. Also, we can use those to simulations, also to create new content using videos. So those kind of areas. Actually, it's been everywhere at the moment. It's been used in everywhere, in every sectors at the moment. So in the image, you can see some of the examples for generative AI tools. There are like ChatGPT, Scribe, AlphaCode, GitHub Copilot. Maybe you also have experience at the moment by using these like ChatGPT and GitHub Copilot, and also BART. So these things also you can study. Like there are like very this is uh, frequently changing. So I was like working few of the use cases earlier in the generative AI side. So it's like today you will go and develop something, and then you go to debug tomorrow. It will be there will be new, like many more new features and ways has been discovered. So if you are interested in this field, you have to be daily updated and use stable versions to code and see. Otherwise, you will face like a lot of issues while working on this field. So yeah, that is uh, about generative AI, and I think now we can move on to hands-on practical session. So I will share the collab notebook. I think everyone can see my collab notebook. So I will give a brief introduction about the dataset that I have been used to do the practical session in here. So basically, this is to predict whether a person, this dataset is being used to predict whether a person is going to have a stroke or not. So here, basically, there are 12 columns. So the basic thing, the mostly basic things that captured in this data set are like gender, age, and their disease types and their smoking status. So as you can see, I have defined here the columns that's been present in the data set. So first is ID, which is a unique identifier. And then gender is available, whether a person is male, female, or other category, and then the age of the patient. Then the hypertension. So if the patient has hypertension, it's being captured as 0, otherwise 1. And then next one is whether the patient has heart disease or not. So here 0 means patient doesn't have a heart disease, and 1 is patient has heart disease. The sixth column explains whether patient has been ever married or not. And seventh column, work type. So there are 5 work types. Yeah, 5 work types: children, government job, never worked, private or self-employed. And then the residence type, rural or urban. And then in the ninth column, average glucose level is being captured. And then the BMI is captured. And 11th column has the smoking status. It's been captured as formerly smoked, never smoked, smokes, or unknown. And in the last column, the stroke is captured, whether it has like 1 or 0. If the patient had a stroke, then it will be 1, and if not, it will be 0. So in the smoking status column, there is a category called unknown, which is that information actually is not a category. It means that that information is unavailable for that patient. So first what I will do is I will mount the drive for me to import the data set. And then I will import the libraries related to the this notebook. And then here basically I have used NumPy. I have imported NumPy, Pandas, Seaborn, Matplotlib. So and also I am using most of the models from scikit-learn package, and XGBoost also used. So these are the main packages I have been used here. So then I have, once I imported the libraries and mounted the drive, in the next code block, I have given the file path for the CSV data file. And after that, next time I'm reading the CSV file to the collab notebook, and then I'm printing and seeing whether the notebook been imported properly. So if we run this, so here you can see gender column, ID column, and there were some null columns here in names. You can see, and this is the unknown for smoking status. So yeah, the data set is been successfully loaded. So now we can see by using this command, the shape of the data set means how many columns and rows are available for this data set. Basically for this data set, there are 5,110 data points are available with 12 columns. So we will see the columns names for this data set. So you can see here ID, gender, age, hypertension, and like all the column names are listed by running this command. After that, we will read it and print the first 10 records of the data frame. So here you can see hypertension is 0 and 1. Type, so disease, heart disease as 0 or 1. Ever married is yes or no. Like that, there's, you can see like age is an integer number, gender is a categorical, ever married is categorical, like that way. You can get overall basic idea about the data set. After that, I'm going to check the I'm going to run this code block and check what about the data frame. So what are the information available about that? So here you can see the column name is given here, and data types for this data set is here. So here you can see all these columns except from BMI has 5,110 data points, but BMI has 4,909. So you can see some data points are missing here, and you can see this side the data types are mentioning. there are like 3 integer 64, object and float 64. So now what we will do is, now we have like normal very basic understanding about the data set. We will conduct exploratory data analysis and get deep understanding about the data set before we go and train machine learning models. So I'm going to see the null values for each and every column. So I can use this command .is null.sum. What this will do is it will summarize all the null value columns and print it here. You can see. So except from BMI, all the other columns are 0. So BMI has 201 null columns. So after that, what we will do is we will calculate the ratio for the missing these are null values. So we can see the ratio is 3.93% is missing from the data set for the BM1. Then what we will do is we will create a new data frame with the missing value counts to plot. So here we have two calculations like missing and not missing. So if you can see here we have separated. Now we can plot the data set here. You can like visually see the ratio of missing and not missing values for BMI. So you can see like missings are very small amount, but yes. So now we go around. What I have done is after checking the missing values, I am checking categorical and numerical variables. So this I have used this call names function. It is being created to get the column names that has the categorical and numerical data separately by using that data types I have derived here. So I can use that and then separate it. So here basically I am defining categorical columns as which are not in the data types, these two like float integer 64 and float 64. And after that I am defining numerical columns as which is the data type which is in integer 64 and float 64. So this is not in and this is in. So that is the difference. And after that, I am assigning a numerical part. It should be categorical. So as you can see in here, so hypertension, like heart disease, like those are like 0, 1. So we can consider those as categorical variables. So therefore, even the stroke, these are categorical, we can consider as categorical, but those are captured as numerical. So what I am going to do is I am going to assign those separately into this variable called num.cat. So what I am doing is I am assigning the columns which has unique values less than 10. So if it is more than 10, I am considering those are as numerical values. If it is less than 10, I am considering those are categorical values. This number is working for this data set. Maybe like if you are using another data set, you may have to check like do some analysis about if you are considering like some other categorical column, how many categories are there, and also if there are numerical columns that you have to consider as numerical, and if it only has 10 different unique values, then you have to mindful about that before using this kind of condition. So it depends on the data set and what you are going to do. So in this data set, this works for me. So therefore I use like that way. And after that, I am assigning categorical columns as the categorical columns that I got from here and also here. So I have now full categorical columns for my data set. So then I am removing that categorical columns that I have considered as that numerical columns that I have considered as categorical from the numerical num calls variable. So this way I am reassigning that column. So now if we run this and then run this one, we call the function here. Now you can see numerical columns are only ID, age, average glucose level, and BMI. And categorical columns are now hypertension, heart disease, stroke, gender, and all been concatenated. You can see. And the categorical but numerical but categorical which was assigned, you can see which were converted to categorical, which was numerical are here. So yeah, so now we know the data types also. Now what we will do is we will analyze the numerical variables and see the behavior of the numerical variables separately. So here what I have done here is I have gotten a basic statistical description about the numerical data. So here you can see the count, mean, standard deviation, mean values, the percentages like the interquartiles and maximums. So you can see those values for each of the variable. Here for the count, again you can see all the other columns and have this 5,000 plus columns, but BMI has 4,000 plus columns because of the null values. Also the mean values are there. For the age, you can see it's 43.22 and glucose level is 106.14, BMI is 28.89. So yeah, so now what I will do is I will plot these in a bar plot and see the behavior of the data. So this is the ID column. Actually, ID column it doesn't have any trend. Normally, we don't consider ID column for predictions. It's just an indicator for each and every data point. And age column, you can see how the distribution of the age, and you can see like 80-year-old people are there, most of them, and in between 0 to 20 and around maybe 65 or so, and then until 80 it's low amount of people. And when it comes to average glucose level, you can see how the glucose level is being distributed. There are like some cases even up to 250 and more than 250 as well. And then the BMI, you can see here how it's been distributed among the data set. Now what we will do is we'll check for the outliers. So here you can see here the sorry. So here you can see ID and then age. Age is fine. And then you can see the average glucose level. You can see some of the data is being spread out here. So which was like in that range of around 175 to 250. So that's there. And in BMI, you can see some outliers are available. So here, some points are available. You can see in for BMI. So now what I am doing is I am checking the outliers using interquartile range for the numerical attributes. So I have created the function uh, to return the columns which has outliers, the numerical attributes. So when I will run this is the function defined. So I'm calling the function, and by this is the data set, like the data frame, and then this is the numerical columns. I'm inputting those to the this function and returning the columns. So outlier columns. So you can see saying that BMI has outliers in the data set. So after that, what I will do is I am going to now analyze categorical variables. So here I am plotting the categorical columns and going to see the distribution of categorical columns. So now you can see hypertension has zeros a lot, but a small amount of ones. And heart disease also the same. It's the other way, like zero has a low amount, but there are the people who have one is a lot in the data set, and stroke is also the same. Then this is a imbalanced data set actually, because if we so this we are going to predict the stroke, so therefore this is definitely the dependent variable. So others will be independent variables. In that case, the stroke class 0 has very low amount of data, where the stroke class 1 has a lot of data points available. So if you can see the gender, the males are high in the data set than the females, and married people are also more than not married. And if you consider the work type, it's, as you can see, the most of the people works at private sector in this data set, and we can see only little amount of never worked people, and others are kind of going closely, but self-employed is the second highest in the data set. In the residents category, we can see that there's no much difference between both, but still urban is much more than the rural. Smoking states, we can see formerly smoked people are high in the data set, and never smoked people are the second highest, and smokes and unknown now, so like going close by, but unknown is the least. So now we have an idea about the categorical data. Now what we're going to do is to analyze the target variable, which is stroke column. So here, as I mentioned earlier, you can see there are little amount of zeros compared to 1. So we will calculate the percentage of zeros and ones. So here you can see 95% 1.1 of the data is available for class C, and for class 0 it's only 4.9%. So it's basically a very biased data set. So we have to think about that before we go ahead with and predict the go ahead with the prediction. So now what I will do is I will check the correlation of the categorical variables. So you can see like there's no much correlation between these variables. So it's because you can see here, if we go to data set, so here only like hypertension, heart disease, those are 0 and 1s, but even age, like gender or types, these are not related to each other. So we can't get a relation between these because of not much data is not like normalized or anything. So it's obvious that we can't get much correlation between each of the variables. So therefore, now what we can have to assume that there are no highly correlated attributes. So now what we will do is we will check the target variable was numerical attribute. So here what I will do is I will group by and then see for stroke ID doesn't make much sense, but when it comes to age, so most of the people who have stroke average age is 66.7 and 0 is 41.1. Likewise, you can see how the mean is being distributed among the stroke and each of the numerical columns. So after that, now I'm going to check the categorical variable versus the target variable. So here also you can see I have got the mean values like after the grouping. So here you can see there are also for the heart diseases, you can see with the stroke, zeros are not more than the ones are a lot more than zeros. So so you can see how the distribution happens among those columns and with the stroke. So from the above results, what we can say is so people with hypertension are more likely to have a stroke. Also, people with heart disease are more likely to have a stroke. And these are the conclusions that we can come to. And the probability of having stroke is higher in men than the women. And also people who have been married are more likely to have a stroke than the people uh, who are being not married. And also people who are self-employed are more likely to have a stroke, and the probability of having a stroke is higher in urban life than the rural, and probability of having stroke is higher in formally smoked people compared to the other people. So now we will do the data preparation for the model training. So I will check for the duplications. And 0, and then I will do the, since there are no duplications, I will go ahead and do the replacing the missing value. So for the BMI, I'm going to use the median rather than removing those values, and replace by imputation using median. So median, and then I'm going to apply the label encoder for the binary columns, which means the unique values are below 0, basically the columns which have 0 and 1. So I'm applying that to make it numerical, and I can see when I assign what are the numerical columns below in value. So I get if I'm married or resident type now. So and then I'm go ahead and do the label encoding, and yeah, so after that you can see if I'm married here, and then resident type column. Now it has been changed. And after that, I am doing one hot encoder for the attribute which has more than 2 categories. So here, running this. And so these are the columns that I am applying one hot encoding for. And here I have applied, and then do this. Yeah, now you can see these columns being like added as separate columns for each and every category in the data set. After that, to deal with outliers, I will replace the those outlying data points with the upper and lower limits. So I'm using an interquartile range method to replace those. So this is the function I am using. So low threshold and upper threshold is given as 0.1 and 0.9, and it can calculate the interquartiles. And after that, setting up the low limit and the upper limit using the this function. So after that, I am replacing. So I have now replaced the outliers with the upper and lower limits. So now I'm going to check the same function to find whether outliers are fixed. Yeah, now it says there are no outliers. Earlier it returned as BMI column has outliers. Now it returns as there are no outliers. So now I'm doing feature scaling. So as you can remember earlier, like the age and everything was like high numbers where these values are very low numbers and much deviated. So therefore, I am doing the scaling. So basically, I'm doing scaling for age, BMI, and average glucose level columns. So I'm using min-max scaler, and now I'm going to see whether it's been applied. So yeah, as you can see, age has been scaled, and yeah, glucose level, BMI, thing is fine. Now I'm going to do the model building. I'm defining the y-axis and x-axis here. So after that, so for the x-axis, I'm dropping the stroke and ID. For the y-axis, I'm only taking the stroke. And these are the classification models that I have been used up to this one. I have been used for this model, this data set to predict the stroke, having stroke or not. So here I have defined the model and the specific function to run the model. So you can see it here. So, and then what I'm doing is I am running. Here I'm running and see the accuracy and like the F-scores for the specific models which I have been used to predict the strokes. So we see. Okay, so it seems like models are not performing very well. As you can remember, the data set wasn't a balanced data set. So I was thinking that thinking it might be the case. And then what I did was I did the sampling. Basically, I used the method called synthetic minority oversampling techniques, where I can use the minor class and then generate more values to that minor class to balance the data set. So that is called SMART. So basically what happens here is it will select the examples that are close to the feature space of the minor class, and then draw a line between the examples in the feature space and um, that new sample, and then drawing a new sample at a point along at that line. And after that, the random sample of the minority class is chosen firstly, and then it will be it will be taking the k of the nearest neighbors for that samples. And basically, if we are not defining, it is considering k as 5, and then it will randomly select the neighbors which is chosen, and a synthetic example is created at a random point, selected point between those two examples in the feature space. So that's what happens basically in this smart sampling. So I am using smart sampling here. So I am defining the smart, and then I am defining the x and y, and I'm creating a test set for 20% of the data set. And then for the y train, I have 203, and then 0 when it's 1 and 0, you can see the difference for ones and zeros. So after that, I'm generating the sample. This will set x train smart and y train smart. So then you can, after that, you can see both of the samples are balanced now. So I'm running the same code here to see the accuracy and precision scores. And scores, now you can see that F score has been increased. So better the when this F score is near to 1, the model performs better. So you can see here it's been increased. Like earlier it was very low. So because of the sampling issues. So I think that is the end of the practical session. So now I can share the slides again, and this is the wrap up. So what we discussed as a reminder, so data types, quantitative data, qualitative data, data type pre-processing techniques, handling missing values and encoding techniques, exploratory data analysis, and machine learning and regression, and also did extra topic as advanced machine learning topics. And then this is the end of the workshop. To take the questions.
Well, thank you very much for such a fantastic presentation, Sanduni. It was truly awesome that you covered so many important topics in machine learning. And we have some excellent questions from the audience, but we only have time for a couple of questions. So let me start with how to tell if the missing data is missing completely at random, missing at random, or missing not at random.
So as I explained, so here what you have to see basically, so here, so if it is missing completely at random, there is no any dependent with the other columns. So the data has been gone missing totally at like randomly. So there's no any relation between other columns. But if it is missing at random, there is a dependency with the other column. Like as I explained earlier, if it is a birthday column and a birth that age is calculated using that birthday column. So both, but you are using only the age for the model building. But in that case, you have to go back and see why the age is missing. In that case, you figure out that the date of birth is missing. That's why the age is missing. So that is called that those kind of situations are called missing at random. And missing not at random means most of the people might, like, most of the data points are not available and it should be answered. So something like that in those situations, like imagine in a survey, you have conducted a survey, and then most of the people haven't answered for a specific question where you can think of that some of the people might also should answer. But in that case, you have to revisit that questionnaires, or the maybe if it is something generated with the pipeline, you have to go to the pipeline and see why it has been happened, if it is because of technical issue, or maybe if it is a questionnaire, whether the question wasn't clear properly. So those kind of things. So those are the two differences of those two. I
Thank you very
think I
much.
answered.
Sorry, thank you very much, Sanduni, for that answer. The next question is, how will you choose the best model from all the possible models in machine learning?
Yeah, so actually that depends. Sometimes even though the model is performing and like it gives the like the, if we can say, it gives the best like accuracy levels, but we sometimes don't use that model in those cases, because sometimes it might be overfitting or sometimes it might be underfitting. So we just can't think about a way that by a training couple of times this model is perfectly working or not. So what we mostly do is we run the same model, or maybe couple of model for the same data set, like maybe 5 times, maybe 10 times, or maybe like for the different, like if we have transaction data, the transaction data might come in a monthly basis. In those scenarios, we have to consider the durations of the months, like those kind of, we have to change the data as well and see where we can get the best model for to go to the production. So for the development is fine, but where we can do the experiment and see with the different models. But when we are going to the production, we have to check in different scenarios. Like maybe a model will be perform very well in the development, but we go to the production with the same model which was very accurately working, and that will not work in the production very well. So sometimes what we do is, one thing is to try different models and see, and other technique is to try different data and different ranges and see. And also we sometimes, most of the times we do, which is called code to production. When we go to the production, what we do is we will run the code in the production and run it and see if there's like model drift or something like that happens, to tackle the issues with the models.
Okay, thank you very much, Sanduni. And the last question, can we consider generative AI is part of deep learning?
I would say we can consider, because basically, so the generative AI, most of generative AIs came under transformers, which was started from GPTs. But like there are some cases, even some of the models are not specifically on the deep learning side. But yeah, we can consider that generative AI in deep learning side.
Okay, well, thanks again, Sanduni, for your workshop and for taking the time today to share your knowledge with us. Thank you very much.
Thank you very much. Yeah.
Okay, and before finishing, we also prepare a special slide for you. If you use the QR code on the screen right now, you can join the WITS Datathon. This is the second challenge, and it's about equity in healthcare. Also, please tune in to our next workshop that is going to happen next Wednesday at 8 a.m. We're going to have a workshop presented by Charity Taylor. The title is Unlocking Success, Harnessing the Power of Ownership, Mastery, Initiative, and Teamwork. This is going to be a workshop focused on career advice and professional development. Also, on behalf of the WITS Workshop Committee, thank you to all the instructors and those who have helped to organize today's event. We are very grateful for your time and efforts. And finally, thank you, the audience. If you can, please take a couple of minutes to fill out our short survey. It will help us optimize these workshops for you. And also use the QR code on the screen to apply to lead a WITS workshop in the 2024 season. And that concludes today's Women in Data Science workshop. See you next week. Ciao.